Hi everyone, welcome back to a video lecture. And in this video lecture, we are learning about the extension. It's a well-known one as an extension or a next version of the Fick's law, that is continuity equation. The Fick's law, so we can write it as Fick's law for the binary system as Fick's law for binary system can be written as ji tilde equal to minus d tilde dou ci into dou x. I have written dou ci into dou x. This means Fick's first law will tell that only the concentration is only the function of position, but it's not true. Concentration is a function of both position as well as time, as I said in the previous section. Ci equal to Ci into x comma t. So we should modify this equation and get the proper equation where the concentration and the flux are related to both position as well as time. Hence, we are deriving considering this type of equation. Okay. First of all, consider the concentration gradient. This is a concentration gradient, higher concentration, lower concentration. Consider the two surfaces, that is surface 1 and surface 2, that is named as dx. Okay, then we can say the flux of plane 1 can be written as ji tilde f1, and it's a second surface ji tilde i2. The overall flux is given by toward this side, and that is ji tilde I, having the cross section area of A. Then we can write it as flux of ji tilde equal to ji tilde of I minus del x by 2 of t, and for the second equation, for the second plane, we can write it as ji tilde of 2, to write it within this only, ji tilde of this one plus del x by 2 with respect to t. then we can write it as considering accumulation of I in time delta t can be written as accumulation of I in time delta t can be written as j tilde of in time t, we need to get it right. So delta t and a, because flux is a function of time and area, that's why I multiplied and we will get the number of terms that is passing. Delta t into a. Then subtracting, so here we got delta ni, right, equal to ji of 1 tilde minus ji tilde of 2, correct, multiply with delta t into a. Okay, by subtracting these two we will get it as, I will make this term towards this side, write it in denominator, and by subtracting these two I will get it as delta x minus delta x dou j tilde to dou x with respect to time. Okay, so from the definition we can say this del ni divided by a is given with respect for unit thickness, we can get it as concentration. To the delta t with respect to x, and here, so this del x is multiplied here and we can get it as concentration here, right. So then here this side it will remains with the negative side, dou j tilde divided by dou x into t. Then this is known as continuity equation. Oh, sorry. Continuity equation. Here the flux and the concentration are related with each other by considering two parameters, that is a position x and as well as time. As we know this from the Fick's first law, J is equals to d tilde into dou c into dou x. And when we are considering, when d tilde is independent of ci, then this can be written as into x d tilde into dou x square with respect to time. And it's famously known as Fick's second law. And we can write this second law as dou ci into dou t, that is dou j I naught divided by dou x, then the j I naught is given as interdivision fluxes in a stationary or lab fixed frame of reference. Interdiffusion flux stationary or lab fixed frame of reference. Okay, then we know that from the previous lecture, ji tilde is equals to ji tilde plus ci into uv. So substituting this value into the above equation, then we can write it as ji tilde plus ci into uv. And by writing differentiating this equation, we can write it as ji tilde into t x ji tilde minus uv into x ci into dou into x. So this is the equation that we will get. And note is a very important to this one is continuity equation. Continuity equation applies only to stationary fixed frame of reference. Stationary fixed frame of reference. Okay. And next, when we are applies this continuous equation to steady state diffusion, steady state diffusion, at any given x plane, the concentration will not vary with the time. That is called steady state. At any given x plane, the concentration will not varies with the time, is called steady state equation. Then the concentration is a function of x and time. This will leads to only function of position. Then dou Ci into dou T at a fixed position will tends to 0. It's not at all function of time right now at that position. Then continuity equation leads to this will tends to 0, and now we can remove this dou and we can make it as complete ordinary differential equation, because its only concentration is only the function of x. D tilde equal to dci into dx square equal to 0. So sorry, I have to write it as multiple sign here. Then differentiating this one, we can get it as dci into dx equal to b value, and again integrating on both sides, ci equal to bx plus a. This is the, as we know that this is in the form of y is equals to mx plus c. This is a straight line equation. This is straight line equation.